Greetings. Welcome to week 7 of our online learning. So for this week, we're going to be focusing on properties of logarithms and how to use them to solve simple logarithmic equations. So before we even begin, I'd like to wish everyone happy Memorial Day, just in case there are people there who actually love Memorial Day. All right, so before we begin with our actual lesson, let's go over the guidelines. All right, so here again we are with our distance learning safety guidelines. So please be reminded that the PGCPS administrative procedures regarding appropriate use of technology, social media, and email continue to apply to our online instruction. In addition, this session may not be recorded without the instructor's consent. Description of the applicable procedures is provided online in the Student Rights and Responsibilities Handbook. Okay, so again, this highlighted phrase, since it's a pre-recording, this is not actually going to be enforced in its exact form. So if you would like to share it with someone who you feel it would benefit them, please let me know so I can definitely give you a written permission through email, of course. And of course, if you would like to read more about online safety and responsible use, you can, of course, go to the student handbook, which is readily accessible through our PG portal. If you do not want to navigate that, of course, you just may go to our Google Classroom, scroll all the way down to the earliest entries, and you will definitely find there a link that would bring you over to the student rights and responsibilities. Okay, now that this one is finished, we can now proceed with our main lesson for the week. So our lesson for the week is properties of logarithms. Okay. All right, so first we have objectives. So at the end of this lesson, students are expected to apply the correct property of logarithms or properties of logarithms, just in case you need more than one property. To simplify complex logarithmic expressions. And number 2, to solve logarithmic equations by converting them to exponential equations and solving them as such. So for this particular exercise or for this particular lesson, you should expect that once you have a particular expression in its logarithmic form, in order to solve them, we're going to convert them back to exponential equation. Okay, first a review. So logarithm is the inverse of exponentiation. Okay, that's what we've actually discussed last week. Okay, so usually if you're going to solve for an unknown exponent, logarithm is the way to go, except if the exponent seems easy enough to determine, in which case an exponential form would suffice. Now, since we are going to be focusing on logarithms, it is important to review how to convert it from exponential form into logarithmic form. So an exponential form of the form m raised to the x is equal to y. So m is referred to as the base, x is the exponent, and y is the power, can easily be converted into its logarithmic form. Logarithm to the power logarithm of the power y to the base m is equal to the exponent x. So notice the way it's written. So the exponent is alone on one side if it's converted to its logarithmic form. The base is somewhat of a subscript. Okay, so for this particular topic, we're of course going to generalize that m, or the base, is always higher than 0. So it could be a fraction, it could be a very big number, but definitely it is a higher number than 0. So it can't be negative, can't be 0. So this is very, very important, as logarithms fail if the base is 0 or negative number. All right, so now we're going to go over properties of logarithms. So take note that exponents also have their properties. I think they are referred to more as laws of exponents. Okay, so properties of logarithms actually have their own properties in connection with these laws of exponents. So the first law of exponent, or the first exponential property, is a base raised to 1 is equal to itself. Thus, the logarithm of a particular number to the same base is also equal to 1. So notice how these two are connected just by converting one form into its logarithmic form. M to the 0 is equal to 1. So any base which is higher than 0 raised to 0 will always be equal to 1. Actually, even if m is negative, but in this case, we're not going to consider the case where m is actually a negative number. Thus, in its logarithmic form, logarithm of 1 to a particular base is also 0. So the logarithm of 1, even at any base, will always give you an answer of 0. Now, to go over the more complex properties of logarithms. So in this case, we're going to be tackling several logarithms. All right. For example, if m to the x is equal to a and m to the w is equal to b, so a and b are both powers. So in such a particular case, if you are taking the sum of the two logarithmic powers, okay, logarithm a to the base m plus logarithm b to the base m, this is just equal to a single logarithm wherein you take the product of the individual powers to the same base. So take note, the only way this works to combine as a single logarithm is if they have the same base. Right? Its basis is in its laws of exponents. Take note, if you multiply two powers with the same base, it is simply equivalent to just adding the exponents. And it's in this case as well. If you are going to add, because remember, logarithms, the answer for logarithms are exponents. If you're going to add the exponents, is equal to the logarithm of the product of the two powers. Thus, it is easily connected that if addition leads to multiplication of the powers, subtraction leads to division of the powers, wherein the positive logarithm, okay, the power which has the positive logarithm is actually in the numerator. So logarithm a, the base m, minus logarithm b to the base m will be equal to logarithm of a divided by b to the base m. Okay, so similar to something like this, right? And finally, what if you have an extra exponent in your power? Your power has an exponent. So if you're taking the logarithm of a raised to w to the base m, okay, so this is equivalent to w times logarithm of a to the base m. So any exponent of the power you are taking the logarithm of, this exponent can actually be converted as a coefficient, meaning it's a number multiplied in front of the logarithm. All right, okay. So I think the next slide might be examples. Let's go over them. Aha, here we go. All right, so here we have several logarithmic expressions. Okay, the goal of this example is to convert them into a single logarithmic expression. Okay, so if you would like to try it out on your own, you may of course pause the video, try it on your own, and then when you're ready, you can unpause the video, and then you can see the solution, and we can discuss whether your answers were correct or not. Okay, I think that should have been enough time for you to have paused and unpaused your video. So we're going to go over the answers and solutions for these. Right, so let me just copy. We're just going to discuss in detail, I guess, numbers 1 and 4. I'm just going to copy 4 here. All right, but I'll definitely show you the answers for everything. All right. Okay. So here we go now. All right. So for number 1, this was number 1. This is number 4. So for number 1, we have logarithm of x minus 1 to the base 5 plus logarithm of x plus 1 to the base 5. Now, if you recall, if you are adding logarithms, that is equivalent to actually multiplying the powers. So thus, this one simply converts to logarithm to the base 5 of x minus 1 times x plus 1. All right. So there you have it. You already have one logarithmic expression here. If you want to further simplify that, you may do so. Now remember, these two are binomials, so therefore you need to FOIL them. However, if you recall that this is an a minus b x a plus b form, then you should be able to say that the product of x minus 1 times x plus 1 simply reduces to x squared minus 1. And this is the correct answer, or the most simplified answer for the first example. Right? So I hope that was clear. All right. So now we go to number 4. So number 4 seems a bit complex. It has 3 logarithmic expressions. All right. So 3, all right, times logarithm of 2 to the base 3 minus 1/2 logarithm of 4 to the base 3 plus 1/3 logarithm of a to the 6th. So this is a to the 6th to the base 3. All right. So the first thing we have to note is that there are coefficients in front of the logarithms. And when you're simplifying logarithms, you cannot have coefficients in front of them. So therefore, we're going to move these coefficients to become exponents of the powers. Thus, it becomes logarithm, right, to the base 3 of 2 cubed, okay, minus, all right. So in this case, we're not going to carry over the minus, just the coefficient, minus logarithm of 4 to the base 3 raised to the 1/2. And then we have plus logarithm of a to the 6th, the base 3 raised to the 1/3. Right? So that is 1/3. I'm sorry, the space is kind of cramped. All right. So before we actually simplify or combine the logarithms into a singular logarithm, we're going to, of course, simplify whatever numbers or expressions can be simplified. So 2 cubed is simply 8. Logarithm of 4 raised to the 1/2, the base 3. Now 4 to the 1/2 is like saying square root of 4. Now remember, a fractional exponent is a radical expression. So 4 to the 1/2 is like saying square root of 4. All right, so this is like saying logarithm of the square root of 4 to the base 3 and the square root of 4. We will not take negative answers. So this is simply logarithm of 2 to the base 3. plus, oops, I think we should use red pen for consistency. It seems like I like the number 4 a lot. Right, so finally we have logarithm of a to the 6th raised to the 1/3, the base 3. Now, since this expression has two bases, has two exponents, 6 and 1/3, we then have to multiply the exponents. So 6 times 1/3 is simply 2. So a to the 6th raised to the 1/3 is like saying a squared. So therefore here, we have logarithm of a squared to the base 3. All right. Okay, now this one is definitely getting better. Now that we have no coefficients in front of the logarithms, we can now combine logarithms, all right, as either products of powers or a quotient of powers. Okay. So first, we're going to write our single logarithmic expression, logarithm to the base 3. All right. Now, 8 is a positive logarithm. There's no negative in front of it. So therefore, it should be on top of your fraction. Logarithm of 2 to the base 3 actually is negative in nature. So thus this 2 should be written below the fraction bar. And then finally, we have the logarithm of a squared to the base 3. Since this one is also positive, therefore a squared has to be written on top of the fraction bar. All right, so here we go now. Okay, now, of course, we can, I think, simplify this one further. So we have logarithm. So 8a squared divided by 2. This is simply 4a squared. I'm going to put it in parentheses just so there is no confusion. Because sometimes if you don't put parentheses, you might think that only 4 is being taken the logarithm of. But by putting this in parentheses, all right, I am clearly telling you that you need to take the logarithm of 4a squared, the complete expression. All right, so therefore this would be number 4's simplified expression as a single logarithmic expression. All right, so let's go back to our lecture and see whether our answers are correct. Aha, so here we go. So for number 1, we have it as logarithm of x squared minus 1 to the base 5. That is, of course, what we got earlier. And for number 4, it's a long process, as you can see. It reduces to logarithm of 4a squared to the base 3. All right, so just in case, you also tried numbers 2 and 3. For number 2, take note it's subtraction, so it's going to be a division of powers. So 18 divided by 3 is 6. And take note, because it has the same base and same power, therefore, its logarithm should just be 1. For number 3, okay, we have this coefficient here, so it becomes a power. 5 squared. 5 squared is simply 25. Because this is an addition, you just have to multiply the 25 and the x. Thus, it's logarithm of 25x to the base 9. All right, so if you got all of them correct, very good job. All right, let's carry on to our next queries. Okay, aha. So this is a very, very important question. Why are logarithmic properties important? Okay, so why do we need to study them? Okay. The thing is, before a logarithmic expression can be converted into its exponential form, there has to be only one logarithmic expression present. Thus, if you have like several logarithms present there, then you cannot convert them. Okay, so thus, it is important that you convert everything to become a single logarithmic expression before you actually convert it back to its exponential form. All right, so this is the purpose of why we are learning the properties. Okay. All right, so here we go. So before we actually go over solving logarithmic equations, we're going to learn about this special logarithms. So special logarithms are logarithms which are not written the traditional way. As you would recall, logarithms are written this way. Log, there should be a power, okay? There should be a base, and it should equal to a particular exponent. Or if not, at least the exponent is blank. That is what you are solving for. But the barest minimum that a logarithmic expression should have would be logarithm, then the power, and then finally the base. Okay. So for special logarithms, some of them might be missing. Some of them looks really different. All right, so here we go. So the two special logarithms are logarithm y is equal to x and ln, or referred to as the natural logarithm. Ln of y is equal to x. Okay, so take note, for the first one, we don't have the base, right? Which is actually an important component of logarithmic expressions. This one is even spelled differently. It's not even spelled as logarithm. So what are the implications of having such logarithmic expressions? Okay, so if you are dealing with logarithm of y is equal to x, not no base indicated, it is understood that the base is 10. All right. So if you do not see a base, automatically the base is understood to be 10. This is the reason for such is this logarithm is based on our numeration system, which is of course powers of 10. All right. Now, if you're of course from this form, it can be converted into its exponential form as 10 raised to the x is equal to y. All right, but take note, given this form, it should be automatically remembered that this form converts to this form. No base written down means the base is understood to be 10. If you have natural logarithm of y is equal to x, right? So this one is also a logarithm, a special one. Its base is a special irrational number called e. Now, e is referred to as Euler's number. So Leonard Euler is a French mathematician. He actually had a lot of contributions in math. So this special number is given with respect to his discoveries. Right, so it has similar to pi. E has very vast applications in calculus. Okay, so if you're given the natural logarithm of y is equal to x, this is understood to be the logarithm of y to the base e is equal to x. Thus, in exponential form, it is automatically converted. E to the x is equal to y. So if you're given with natural logarithm of y is equal to x, if you would like to convert it to exponential form, it converts as e to the x is equal to y. Just so you know, if you're wondering, what is the value of e? E is approximately 2.71. Similar to pi, pi is approximately 3.14. E is approximately 2.71. All right, so now that we understand, or now that we know what special logarithms are, right, let's now try to understand what are the steps in solving logarithmic equations. Okay, so logarithmic equations, there's actually only 2 steps. So let's try to go over them. So the first step is to combine all logarithms. Okay, so this is logical because as I mentioned earlier, you need to combine all logarithms into a singular logarithmic expression so that you may be able to convert it into its exponential form. All right. So you combine all of them. Okay, that's great. Okay. Then once you've combined all of them, you are to convert it to exponential form. And once it's an exponential form, you solve it as an exponential equation. Ha, okay. All right, so after you convert a particular logarithmic expression that is exponential form, we are now going to solve it as an exponential equation. So therefore, the steps for exponential equations still follow, which is number 1, remove a and k. Number 2, make sure that all terms have the same basis. And number 3, once all the bases are the same, you are to equate the exponents with each other. All right, so I hope you still remember that from the previous lesson last week. So if not, of course, do find time to actually review those steps and how they are solved as exponential equations. Okay, so here we go now. So here we have 3 examples of logarithmic equations. We have logarithm of x plus 1 to the base 6 plus logarithm of 4 to the base 6 is equal to 2. We have number 2, logarithm of x plus 30 is equal to 1 plus logarithm of x minus 6. And finally, we have 2 logarithm of x to the base 2 is equal to logarithm of 9 to the base 2. Right? Okay, so if you would like to try this out on your own, of course, you may do so. You may pause the video right now, try solving it, and then when you're ready, you may unpause the video and then check your answers with the solution I will be presenting. All right. I think that should have been sufficient time for you guys to have paused the video and then try to do it on your own and then finish and then unpause the video. Okay, so now we are going to go over the solution. I'm going to go over the solution for all 3 of them, so hopefully it won't take too long because I don't want to actually make the video too long. All right, so let's go to our whiteboard. All right, so here we are. The first equation, logarithm of x plus 1 to the base 6 plus logarithm of 4 to the base 6 is equal to 2. Now take note, there are 2 logarithmic expressions here. So the first step is to actually make sure that they become one logarithmic expression. Okay, so take note that this is an addition of logarithms. So therefore, x plus 1 and 4 must be multiplied with each other. Aha, there we go. All right, just take note, it's an addition of logarithms. Thus, the powers need to be multiplied together. All right, we're going to simplify this. So 4 times quantity x plus 1. So don't forget that this has to be distributed over the expression. Okay, here we go. Logarithm of 4x plus 4 to the base 6 is equal to 2. Now that it is a single logarithm now, we can go to step 2, which is to convert into exponential form. So 6 is the base, so it's 6 raised to the, remember, logarithm solve for exponents, so the number alone has to be the exponent, is equal to the power. 6 squared is equal to 4x plus 4. Now it's algebra time. So 6 squared is 36. We subtract 4 to both sides. Divide by 4. Thus, we get x is equal to 8. All right. So I hope you got that. Okay. So we're going to go back to the main slide to see what the second equation is. It was too short of a time in my time for me to actually have written it down. All right. So just give me 1 sec. Let's just switch back to that. All right. So for number 2, we have logarithm of x plus 30 is equal to 1 plus logarithm of x minus 6. All right, now that I have copied it, I'm going to switch back to my whiteboard. Okay, here we go now. All right, so the intriguing part for this one is that the logarithms are actually found on opposite sides of the equation. So how are we going to do this if they are found on opposite sides of the equation? So the secret is actually to treat these logarithms as just like any algebraic term. So to move logarithm x minus 6 onto the other side, because we want them all on one side, we're going to subtract logarithm of x minus 6. Okay, so thus, this one now becomes logarithm of x plus 30 minus logarithm of x minus 6 is equal to 1. Okay, take note, when you are subtracting logarithms, you do not subtract the expressions inside. No, don't subtract them. All right, so it just simplifies as a difference between two logarithms. All right, so the only way you can subtract logarithms is if they also have the same powers. All right, so in that case, you only subtract their coefficients if they have coefficients. All right, so now that we have put all the logarithms onto the left side, what are we going to do? Okay, we're now going to continue simplifying the logarithms by converting it into a singular logarithmic expression. So logarithm of x plus 30 minus, so take note, there's a minus sign here. So thus, it is simply a quotient of logarithms. All right, so here we go. So we have logarithm x plus 30 minus logarithm of x minus 6. All right, is equal to logarithm of the quantity x plus 30 divided by x minus 6. Now that we have finished step 1, which was to make sure that it's a singular logarithm, we are now ready for step 2, which is to convert to exponential. So notice, as you would convert to exponential, it's actually missing a base here. All right, it's not mentioned. Okay, but take note, as I mentioned earlier, if it's missing a base, the base is understood to be 10. Right? This can be thought of as logarithm of x plus 30 over x minus 6 is equal to 1. All right. So therefore, if the base is 10, then as an exponential equation, this is 10 base raised to the exponent is equal to the power. Right? So we further simplify. There's no more space at the bottom. I'm going to slide over here. So 10 raised to the 1 is simply 10. So this is 10 is equal to x plus 30 over x minus 6. Okay, so to easily understand this one, I think the easiest way is to just think of it as cross multiplication application. You can think of it as rational expressions multiplied by LCD, in which case multiply x minus 6 to both sides. But I think it's always easy enough to remember that in such a case, cross multiplication is easier to remember. So when we cross multiply, so 10 times x minus 6 is equal to 1 times x plus 30. So 10x minus 6 is equal to x plus 30 because it's only 1. 1 multiplied to anything is, of course, equal to itself. So now we distribute. We have 10x minus 600. Oh, I'm sorry. Why was that 60? I was too fast. It's only x minus 6. So this is only 10x minus 60 is equal to x plus 30. Right? So my goal is, of course, to put all the x on one side and all the numbers on the other side. So what I'm going to do, I'm going to remove the x here by subtracting x to both sides. All right, so all the x terms would be on the left side because this will be removed. And then I'm going to also remove all the numbers from the left side so that all the numbers would be on the right side. So this, we have 10x minus x, that's simply 9x, is equal to 90. Right, we divide by 9, and we see x is equal to 10. All right. Okay, so this particular case, x is equal to 10. All right. Okay, so we finished 2 out of 3. Now we're down to our last one. All right, let's go back to the main slide again. Look at what the question is, and then, of course, solve that. All right, so we have 2 logarithm of x to the base 2 is equal to logarithm of 9 to the base 2. All right, okay. All right, so first up, okay, we can simplify this in several ways. We can move this logarithm first. All right, move this logarithm first onto the left, or we can actually take care of the coefficient first to become an exponent of your power here. So we'll do the conversion to the exponent first. So this 2 becomes an exponent of x. So thus this becomes logarithm of x squared to the base 2 is equal to logarithm of 9 to the base 2. Right. Now for some of you, and I do notice this, for some people, what they would usually do is they treat this as like exponential equations. Oh, look, this is logarithm to the base 2. This is also logarithm to the base 2. So therefore, x squared is equal to 9. We take the square root of both sides. So x is equal to either positive or negative 3. All right? So that is one way of looking at it. However, this logic, the conversion from logarithm to just canceling out the logarithm, so as to speak, is actually an incorrect logic. I mean, the answer is not incorrect. Let me clarify that. The answer is not incorrect. The logic is incorrect. You cannot make that jump to simply just canceling out logarithms. All right, so I'm going to go over the regular step. But if you're in a test and time is of the essence, of course, you can just go and cancel them because it leads to the same thing. Okay. But of course, it's important that you understand what the correct process is. I mean, how it eventually goes to x squared, square root of x squared is equal to 9. All right. So first, because the logarithms are opposite sides, we're going to subtract. logarithms. Okay, so this one zeroes out, right? Division, because it's a subtraction of logarithms. All right, and now we are ready for an exponential form. 2 raised to the 0 x squared over 9, and 2 raised to the 0 is simply 1. All right. So now that you have this, of course, we can now proceed with cross multiplication, and then you lead up to that particular expression. So by simply canceling out the logarithms here, you actually skip several steps of logical process. Not saying that eventually this one becomes incorrect. I'm just saying that the logic of just simply canceling the logarithms is incorrect. So if you need a formal answer, you actually need to go over the whole process. But if you are pressed for time, of course, you can skip the process, knowing that you can just cancel out the logarithms. All right. Now, take note, since we have two answers here, x is equal to positive or negative 3, the question is, are both answers acceptable? Actually, no. Right. Why? Because the negative 3 component, actually fails if you take its logarithm. 2 times logarithm of negative 3. All right. The problem with this one is that there is no exponent for 2 such that it becomes negative. There is no such exponent. I mean, probably an imaginary one, if it's even possible to imagine that. All right. So thus, having a negative 3 as a power to take a logarithm of is actually not acceptable. So therefore, the only acceptable answer here is x is equal to 3. All right. So I hope that this week's lesson is quite clear. If you actually have questions, don't forget that you can actually post questions on the weekly Google Docs, and I can address it from there. Okay, so hope you guys stay safe always. This is Mr. Trusino saying bye and see you next week.